This is day 15 of Advent of Cyber 2025. This challenge is called Web Attack Forensics Drone Alone. TVFC's drone scheduler WebUI is getting strange, long HTTP requests containing base64 chunks. Splunk raises an alert. Apache spawned an unusual process. Some endpoints, these requests cause the web server to execute shellcode, which is obfuscated and hidden within the base64 payload. For this stream, your job as the blue teamer is to triage the incident, identify compromised hosts, extract and decode the payloads, and determine the scope. You use Splunk to pivot between web, logs, and host-level sysmon telemetry. Follow the investigation steps below. Each corresponds to a Splunk query and investigation goal. So the learning objectives for this are to detect and analyze malicious web activity through Apache access and error logs, investigate OS-level attacker actions using sysmon data, identify and decode suspicious or obfuscated attacker payloads, and reconstruct the full attack chain using Splunk for blue team investigation. For this challenge, we need both the VM and the attack box. So logging into Splunk. After you have started the attack box and the target machine in the previous task, allow the system around 3 minutes to fully boot. Then use Firefox on the attack box to access the Splunk dashboard at the IP address of the virtual machine, then port 8000. Then there are these credentials here which we need to be used. I'll just continue reading through until everything is booted up. So you log in with the credentials of blue and then pass1234. After logging in, you'll be taken to the search page. Make sure to adjust the Splunk time ranges to include the time of the events. So e.g. last 7 days or all time. Probably best to do all time because you may be doing this in the future while the logs are at a certain point in time. So detect suspicious web commands. In the first step, let's search for HTTP requests that might show malicious activity. Query below searches the web access logs. That includes signs of command execution attempts. So it's using the Windows Apache Access Index, and it's searching for strings containing cmd.exe or PowerShell or PowerShell.exe or invoke-expression. With the results of this query, it's then creating a table, and it's going to be using the values of time, host, client IP, URI path, URI query, and status for that table. As you can see in the screenshot here, the time, host, client IP, and so on. At this point, we are primarily interested in base64 encoded strings, which may reveal various types of activities. Once you spot encoded PowerShell commands, decode them using base64decode.org. You'll open up in a new tab for later, or your favorite base64 decoder to understand what the attack was trying to do. Based on the results we received, let's copy the encoded PowerShell string. So let's copy this, then place it into the base64 decoder. So decode from base64, I'll decode it into UTF-8, like so, and doesn't look, has some weird characters, but you can see this is now mine. Wahahaha. That's what base64 decodes into. Looking for server-side errors or command execution in Apache error logs. So we're now using the Windows Apache error index and searching for logs which contain cmd.exe, PowerShell, or internal server error. This query inspects Apache logs for signs of execution attempts or internal failures caused by malicious requests. And in the screenshot, we can see there's a log that came up. So if a request like /cgi-bin /hello.bat parameter of cmd equals PowerShell triggers a 500 internal server error, it often means the attacker's input was processed by the server but failed during execution. Key sign of exploitation attempts. Checking these results helps confirm whether the attack reached the backend or remained blocked at the web layer. Trace suspicious process creation from Apache. So let's explore Sysmon for other malicious executable files that the web server might have spawned. We will do that using the following Splunk query. So now using the Windows Sysmon index, the parent image is set to, it can start with anything, but it must end with httpd.exe. So the asterisk, the httpd.exe might be in a different directory location. So the asterisk just verifies that it can be in whatever directory, as long as the process is just httpd.exe. Well, my attack box has come up now, so let me just quickly get up to scratch with where we are. Okay, so I've now got my Splunk back and set up. So we'll copy and paste this httpd query in. We'll run it. We first need to set the time range to all time, so I make sure I get all the logs for it. And we've got 14 events. It's saying to select view table. So I'm assuming that's here, view table, correct? It's now turned all the fields into columns of the table. Typically, Apache should only spawn worker threads, not processes like CMD or PowerShell.exe. So if we see results where child processes have parent image as http.exe and the image is cmd.exe, then it indicates a successful command injection where Apache executed a system command. This finding above is one of the strongest indicators that the web attack penetrated the operating system. So I'm trying to, let me just go full screen with this because I can't see anything. Okay, we can see now image got cmd.exe, and in our query we specifically looked for the parent image as http.exe. So there is sign of compromise with that. Confirm attacker enumeration activity. In this step, we aim to discover what specific programs we found from previous queries do. Let's use the following query. So we're looking at sysmon and we're checking for logs where anywhere within it, it contains cmd.exe and who am I. Go back to here. See in command line, there is who am I command being ran. So attackers often use the who am I command immediately after gaining code execution to determine which user account the malicious process is running as. Finding these events confirms the attacker's post-exploitation reconnaissance, showing that the injected command was executed on the host. So identify base64 encoded PowerShell payloads. So in this final step, we will work to find all successfully encoded commands. To search for encoded strings, we can use the following Splunk query. So within sysmon index, they're looking for where PowerShell.exe was executed, and the command line has enc or dash encoded command or base64 included within it. So let's paste that into here. I need to paste it into here first, and then here. So we're looking for where PowerShell is used to run base64 encoded strings. That appears to not have come up with anything. So this query detects PowerShell commands containing encoded command or base64 text. Common technique attackers use to hide the real commands. If the defenses are configured correctly, this query should return no results, meaning the encoded payload, such as wahahaha message, never ran. If results appear, you can decode the base64 command to inspect the attacker's true intent. Okay, so now on to the questions. What is the reconnaissance executable file name? I think they're talking about whoami.exe. Yeah, okay, that's correct. And what executable did the attacker attempt to run through the command injection? Okay, so the command injection, let's go back. I assume that would be this search query. And this is talking about where it failed. Does that make sense? This is where they attempted to run it. Okay, no, there's no direct information in that. It looks like there should be. Maybe I need to include more properties or switch from table to just event. So, okay, we can see here, this is the encoded. Was that the one that we looked at before? I don't think it is, but so let's grab this and we'll copy it and copy from here. Oh wait, that is the one that we looked at. Okay, so what could it be? What executable did the attacker attempt to run through the command injection? This PowerShell is talking about? Oh, okay, it is. So that's day 15 of Advent of Cyber 2025 complete.